Good morning, students. Today, let us study the lesson 9 Atomic and Nuclear Physics, and we see the topic X rays. X ray Introduction. We are already studied quantum theory of radiation and it deals with photoelectric effect. What is photoelectric effect? The ejection of electrons from the metal plate when illuminated by light of suitable wavelength is called photoelectric effect. Discovery of X-rays. Wilhelm Röntgen was discovered in 1895 that whenever a fast moving electrons fall on a certain materials, then it will produce a highly energetic radiation is emitted. At that time, the region was not known. So that ray were called X-rays. The X-rays wavelength range is short wavelength and it's starting from 0.1 Armstrong to 100 Armstrong. These rays are travels along straight lines with velocity of light, and these lines are not affected by electric and magnetic fields. X-rays photons are highly energetic waves. They can pass through materials which are produced visible light. The quality of X-rays is depends on the highly velocity of the electrons strike the target material and the atomic number of target material. The intensity of X-rays is depends on the number of electrons striking the target material. Productions of X-rays. A discharge tube is used to X-ray as shown in figure 8.20. F is a tungsten filament and it heated by battery. As a result is electrons are emitted from by thermonic emission. A high voltage is applied in between F and the anode plate and the electrons are accelerated to high speeds. The tungsten and molybdenum pieces are added in the face of the copper anode plate. This plate is fitted with 45-degree angle. This plate's electron beam is emitted X-rays. The copper anode plate is target material. This material is affected from high speed electrons. This material is affected from high speed electrons. Now the electrons are decelerated suddenly and lose their kinetic energy. This time it will produce X-ray photons. This time the electron's kinetic energy is converted into heat. So this time is to produce overheat is formed. So the target material is made up of a high melting point metals and cooling system is applying in a surrounding area. Now let us study the topic continuous X-ray spectra. The X-ray spectrum which consists of radiance of all possible wavelengths with a certain minimum wavelength equations which depends on the voltage across the electrodes. This is explained on the basis of photon theory of radiation. When a fast moving electron penetrates and approaches a target nucleus, the interaction between the electron and the nucleus either accelerates or deaccelerates it, which result in a change of path of the electron. The radiation produced from such deaccelerating electron is called Bremsstrahlung or braking radiation. The energy of photon emitted is equal to the loss of kinetic energy of the electron. When the electron is give all its energy, then photon is emitted with highest frequency mu 0. The initial kinetic energy of an electron is given by EV, where V is the accelerating voltage. Therefore, we have H mu 0 is equal to EV. Mu 0 is equal to C by lambda 0. So, Hc by lambda 0 is equal to EV. Lambda 0 is equal to Hc by EV. When lambda 0 the cutoff wavelength, then substituting the known values in the above equation, in this equation. So, now we get the value of lambda 0 or the cutoff wavelength. Lambda 0 is equal to 12,600 Armstrong divided by V. Lambda 0 is equal to 12,600 by V Armstrong. So, this relation is known as Duyen-Hunt formula. That's all.